Good morning, students. Today we are going to discuss one of the basic law of electricity, which is known as Ohm's law, and it's a basic law regarding the flow of electric current, which is established by G.S. Ohm. So what does it say? The Ohm's law says that when an electric potential is applied across a conductor, then there will be a flow of electric current, and that flow of electric current and the potential difference across the ends of the conductor will be directly proportional to each other. Let's take a conductor. And potential difference V is applied across this conductor, and then there will be a flow of electric current. And if we take the ratio of this potential difference and electric current, then that ratio will be a constant, or this potential difference across this conductor is directly proportional to the electric current flowing through them. So we may say that V is directly proportional to I. So here we know that there is a proportionality sign, and in order to avoid this proportionality sign, we need to multiply this term with a constant. So we will get V is equal to R into I. And here the R is known as the proportionality constant, and we call it as the resistance of the conductor. So from this equation, we can get R is equal to V divided by I. So what is this term called? The term R is called as resistance. What does the resistance means? The resistance of a conductor is a characteristics of the conductor. When an electric current flowing through a conductor, the conductor opposes the flow of electric current through it. So that means the free electrons present in the conductor is responsible for the flow of electric current through them. And when these free electrons moving along this conductor from one end to another, then what happens? This free electron has to face collisions, a number of collisions inside the conductor, or the particles present inside the conductor. That may be the atoms, free atoms, or the atoms of the materials and other electrons. They may continuously undergo a collision, and this collision opposes the flow of electric current, and that property of a metal or material is known as resistance. So resistance R is equal to V by R. As we already seen from this equation, V by R is a constant. R is a constant here. So that means the R does not change when the electric current, the flow of electric current increases, or the applied potential difference is increased. Okay, the R is independent of the voltage and electric current. So let us see what will happen to the resistance R if we increase the electric current or the potential applied across the conductor. So let us see, if we double this potential difference, if the potential difference across the conductor is doubled, automatically the electric current flowing through also will increase. So we say, if we take the ratio, if V is 2V, that means the value of V is doubled, then what will happen? Automatically the value of I also will increase. So that will be 2I, and this 2 and 2 will be cancelled, and what is the ratio? The same ratio will remain. And what will happen if we increase the V 3 times? Then definitely the current also will increase 3 times, and again see, the same ratio will remain. That means, that is what we have seen here. The first, V is directly proportional to I means. That means when the potential difference across the conductor is increasing, and automatically, accordingly, the current flowing through them also will increase. So its ratio is a constant. That constant is known as resistance. Unit of resistance is known as ohm. The unit of the resistance is known as ohm. So when we say that 1 ohm resistance is for their a material. So 1 ohm is equal to when 1 volt of current is flowing applied across the conductor, across a conductor, then what will happen when 1 ampere of current is produced flowing through the conductor, then we call it 1 ohm. Okay, 1 ohm can be defined as when a 1 volt of voltage is applied across the conductor and when 1 ampere of current flowing through them, then the term is known as 1 ohm of resistance that particular material has. So as I said, the resistance is independent of voltage and current. Then what does it depends? So the resistance of a conductor depends on few factors. Okay, and assume that if you take a conductor whose length is 1 meter, okay, 1 meter, then the resistance of that particular metal is fixed. Okay, so if you take 1 meter conductor and again a half meter conductor, so which one will have the more resistance in it? Definitely the conductor which has the higher length has the more resistance. That means when the length of the conductor is increasing, so the free electron has to move more or travel more distance. When it travel more distance, these free electrons have to face more collisions with the particles present in the conductor. So that means the flow of that free electrons discontinued there, so that it takes more time to reach the other end of the conductor. So that means what? And that is a time we say that the resistance. Okay, that means the resistance of a conductor whose length is more. Okay, but comparatively, if you take the half meter of conductor, then the resistance will be, even if you take the same material, the resistance will be less than the which has the higher length. Why? Because the free electrons face lesser collisions while traveling a smaller distance. So that is the first factor by which the resistance of a conductor depends, that is length of the conductor. When the length is increasing, then the resistance also increasing. So length is directly proportional to the resistance. We take a thin wire. In a thin wire, then the movement of free electrons will be much difficult than a thick wire. So the thick wire has more area and more free space to move for the free electrons. But in a thin wire, the space will be very less, and also it has to, the movement of the free electrons will not be much easier in the in a thick wire. So therefore, that means a thin wire will offer more resistance. That means what? The area of cross section. Area of cross section is the another factor on which the resistance of a conductor depends. So when the area of cross section increases, then the resistance decreases. So the area of cross section decreases, then the resistance will be increasing. So we say that area of cross section of a conductor is inversely proportional to the resistance. And now we can combine these two equations. Okay, we combine these two equations. So first one is what? Length is directly proportional to R, and area of cross section is R is inversely proportional to A. And if we combine these two equations, we can get R is proportional to L by A. And then the another term that we call, take here this proportion in order to avoid this proportionality constant sign. So we will multiply this term with a constant, and that term is known as rho. And this rho is known as the resistivity. Rho is known as resistivity of the material. is also known as the specific resistance of a conductor. So what does mean the resistivity? So as I said, here two factors we have already learned that by which the resistance of a conductor depends, that is the length and area of cross section. And third is the nature of material. Okay, different materials have different resistance. So that means all the metals do not offer the same amount of resistance to the electric current. So different materials offer different amount of resistance to the flow of electric current to them. So therefore, the nature of the material also depends on the resistance of a conductor. So here the term resistivity. What is resistivity? Resistivity is known as a characteristics of a material. Okay. Here the resistivity does not depends upon the flow of electric current or the potential difference across the conductor, but it's a characteristics of a material. That means these characteristics may be different in different materials. Okay, so the resistivity, we say that R is equal to rho into L by A, where L is the length of the conductor, A is the area of cross section of the conductor. When we talk about a conductor, the resistance and the resistivity rho both are same. Okay, so that means R is equal to rho. The resistance offered by the conductor, that is called the specific characteristics of that material, that is called resistivity of that particular material. So now we have another equation, how we can define this resistivity of a material with respect to the drift velocity and the area of cross section and length of a conductor. So in previous sessions we have learned that electric current I is equal to N into E into A into Vd. So here what is Vd? The Vd can be also written as N into E into A into Vd can be written as E into E tau by M. Okay, Vd is the drift velocity. The drift velocity can be written as E into E tau divided by M. The electric field E can be written as dV divided by dr. Well, what is dV? Here the V is the potential difference across the conductor and R is the distance between them. What distance between them? What is that distance between the two ends of the conductor? And that is normally we denoted as the length of the conductor. Okay, so E is equal to dV divided by dr, and this dV divided by R, this also can be written as, okay, V is what? The potential difference can be written as V, and dr is the distance between the two ends of the conductor, and that can be taken as the length of the conductor. So E can be rewrite as V by L. Therefore, the equation I can be rewritten as N into E square A tau by M, and now the term E we are taking out and can be written as V by L. Now on simplification we can get M into L divided by N into E square tau into A, and this can be written as, so we will get a ratio as is equal to V by I. Okay, so this I and V will take out the ratio V by I. And what is V by I? V by is the resistance R. Okay, therefore this can be written as V by I can write as R is equal to M into N into E square tau, and here the term L by A, L by A. So then we separate these two terms L by A. So this term, okay, what is M divided by N into E square tau can be written as, we can write R is equal to M divided by N into E square tau can be write as the rho into L by A. Okay. And this is what we have already derived in the previous session when we talk about the, so see, L is the length of the conductor, A is the area of cross section of the conductor. So this equation already we have derived previously when we talk about the characteristics of by which the resistivity of a conductor depends. So we say that R is proportional to L by A. The same equation we have got the equation for the resistivity. Let us see what are the factors on which the resistivity of the conductor depends. So here, if we take instead of rho, we will consider this equation. Here see, E is the charge of the electron and M is the mass of one electron. And these two terms are not changing at any of the circumstances. The charge of the electron will not change and mass of the electron will not change. And now, what are the factors on which the resistance or the resistivity of a conductor depends? Here two terms, the N. What is N? N is the number of free electrons per unit volume. So that is the first factor by which the resistance of a conductor or resistivity of a conductor depends. The number of free electrons per unit volume. And if the number of electron is increasing, going up, then what will happen to the rho, the resistivity of the conductor? The resistivity of the conductor decreases. Okay, that means more number of electrons, okay, they decreases the resistivity of the conductor. Then, if the resistivity is decreasing here, and what will happen to the resistance? The resistance also will decrease here. Okay, so if the number of free electrons per unit volume increases, what will happen? So the free electrons, more number of free electrons decreases the resistivity of the material, so the resistance of the material also decreases. Temperature. How the temperature affects the resistivity of a material? If the temperature increases, the value of tau will decrease. If the tau is decreasing, definitely the resistivity increases, so that the resistance also will increase. Okay, these are the two terms by which the resistivity of a conductor depends on. Then how does this resistivity or which materials provide more resistance? Let me say that so insulators. So insulators have the high resistance. Okay, the materials, insulator materials, they provide high resistance. Why? Because there is no flow of free electrons in the insulators, and therefore it has the maximum resistivity or resistance or specific resistance in the material. And second, it has to be what is the second type of material? Semiconductors. Okay, three types of conductors we have: insulators, semiconductors, and conductors. So the next, insulators. Insulators next is semiconductors. But another type of material which has higher resistance than the insulators, they are alloys. Why alloys? Alloys provide more resistance than the semiconductors. Why? Because alloys are the mixture of metals. When the two metals are mixed together, that changes the texture of the metal or material, and also it changes the structure or behavior of metals, so that more it leads to more collision, and also leads to the it does not allow a free movement for electrons through the metal. So therefore the alloys provide much more resistance than the semiconductors. And next is semiconductors, and then conductors. So these are the serial. Okay, there is a order of the material that on decreasing the resistance or the resistivity of the material. First is insulators that provide maximum resistance, and then alloys. Actually it should have been semiconductors, but it is alloys. Why? Because it's a mixture of metals that provide much more resistance against the flow of electrons. Then again next semiconductors and then conductors. And I hope you understand. Thank you.